Hey Year 7s, we're going to go through exercise 5C, which is on equivalent expressions on page 279 of your textbook. So, two expressions are equivalent if they are always equal regardless of what numbers are substituted for per numerals. Now, that's a bunch of words, but essentially when we're talking about equivalent, it's the same as when we're talking about equivalent fractions, equivalent expressions. If they're the same expression or same fraction, we call them equivalent. It doesn't matter if the number's a little bit different, as long as it still gives the same values. So, for example, if I have x plus 12, and I have 12 plus x, they're both equivalent because it doesn't matter if I add the 12 first or the x first, it doesn't matter. The order that we add numbers is not important, so they are equivalent. Another example, 3k is the same as k plus k plus k because, well, multiplying by 3 is the same as adding itself 3 times. So, for example, if I've got 3 times 2, so 3 times 2 is the same as 2 plus 2 plus 2. We're just adding itself 3 times. So, when we multiply, we can actually just add it that same number of times, and that gives us an equivalent expression. We can actually use a table of values to test whether expressions might be equivalent. So we can actually fill in a table like this to go ahead and find whether these expressions might be the same. So state the missing numbers in this table. We're using the same skills we learned last lesson by substituting values. So if I ignore all of this side and I focus on this box over here, right, I'm going to say, well, when x equals to 0, what is 5x plus 3? Remember that there is a times there that you can't see. It's super small. So 5 times x, in this case, is 0. So 5 times 0 is still 0. And then a plus 3, which gives us 3. If I have 1 there, 5 times 1 gives me 5, plus 3 gives me 8. Next one, 5 times 2 gives me 10, plus 3 is 13. And 5 times 3, which is 15, gives me 18. And you can see I'm going up by 5s, but that's not exactly what we're focusing on today. Up next, I've got 6x plus 3. When I have x equals 0, so remember it's 6 times 0 gives me 0, plus the 3 gives me 3. And so far, it looks like they could be equivalent fractions, but let's keep going. 6 times 1 gives me 6, plus 3 gives me 9. 6 times 2 gives me 12, plus 3 gives me 15. 6 times 3 gives me 18, plus the 3 gives me 21. As you can see, it's very clear. These are the same, but as we keep going, they get further and further and further apart, right? So the distance between these is 0. Distance between there is 1, 2, 3. You get the idea. So the question is, are 5x plus 3, and I'm reading this over here, are 5x plus 3 and 6x plus 3 equivalent fractions? No. No. Because if they were equivalent fractions, no matter what number I choose, these numbers should all be the same, and we can tell they are not, which means they're not equivalent fractions. So let's put that into practice. All right, so I've got which two of these expressions are equivalent to I've got 2a plus 6, 6a plus 2, a plus 3, and then all that times by 2, and then I've got 8a. So what I'm going to do is I'm going to construct a table of values. So I've got 2a plus 6, I've got 6a plus 2, got a plus 3 times 2, and I've got 8a. And then over here, I'm going to say x equals to 1, x equals to 2, and x equals to 3. I'm going to go ahead and use my ruler and just rule that out so we can see. It's not going to be perfect, so I apologize in advance. All right. Okay, so hopefully this is making sense to you, what I'm going to do is I'm going to substitute those values in to see if they make sense. So let's start with x equals to 1 on the first column. So I've got 2a plus 6. So if I substitute x equals to 1, it should, sorry, not x, my apologies, that should say a, because we're working with a, not x. Okay, now let's go ahead and do that. So I've got a equals 1 in the first one, so 2 times 1. I'm focusing on this one over here. So 2 times 1 gives me 2, plus the 6 gives me 8. And then I've got a is 2, so I've got 2 times 2, which gives me 4, plus the 6 gives me 10. And I'm doing these in different colors on purpose, and I'll show you later. I'll explain it later, sorry. I've got a equals to 3, so 2 times 3 is 6, plus 6 gives me 12. Okay, let's start with the second one. I've got 6 times a plus 2. So if a is 1, I get 6 times 1, which gives me 6, plus the 2 gives me 8. Up next, I've got a equals to 2. So 6 times 2 gives me 12, plus 2 gives me 14. Because 6 times 2 is 12, plus 2 gives me 14. Up next, I've got a equals to 3. So 6 times 3 gives me 18, plus 2 is 20. Okay. Now let's go with the third row. I've got a plus 3 times 2. So 8 is being 1, gives me 1 plus 3, which is 4, times 2 is 8. Up next, a is 2. So 2 plus 3 is 5, times 2 is 10. Oops, I forgot to change color. And then I've got a equals to 3. So 3 plus 3 is 6, times 2 gives me 12. Hopefully you're starting to see a pattern, but I'm going to keep going so we can finish this off. I've got 8 times a, sorry. 8 times a, so if a equals to 1, 8 times 1 gives me 8. If a equals to 2, I've got 8 times 2, which is 16. And then finally, I've got a equals to 3, which gives me 8 times 3 is 24. Alright, hopefully you can see. Now, I've written them in different colors so you can see that they should be the same number. Assuming they are equivalent, they should be the same number if they're the same color. If we look at the first column over here, we can see that they're all the same number. So far it looks like they could be equivalent. If I substitute a equals to 2 over here, then I know that, well, for 2a plus 6 in the first row and a plus 3 times 2 in this third row, they're the same. And if I look over here, they're also the same over here. So these two, this row over here and this row over here, have equivalent expressions, while the other ones do not. So which two of these expressions are equivalent? 2a plus 6 is equivalent to bracket a plus 3 bracket times 2. And that's how we solve that. Hopefully that makes sense. Let me know if you need any help.